This is going to be a discussion of an issue that Sun's bringing up to customers these days about byte ordering. And you might hear Sun coming back at you through your customers when your customers ask you some of these questions. For example, why is it that DEC's byte ordering is backwards? Everybody else in the industry uses big Endian byte ordering and DEC uses little Endian byte ordering. A different form of the same question might be something along the lines of, why is it that DEC uses a different version of the MIPS chips than everybody else in the industry? The reason that they do that is because they're closed and proprietary. Or a third possible way that the question might be phrased is that DEC can't integrate well with other Unix systems because they use a different byte ordering than everybody else uses. You have a number of different responses that you can come back with for all these different questions. The first is, why did Digital actually choose to go with little Endian byte ordering in the first place? A little bit of history helps when you understand why we did what we did. First of all, we wanted to be compatible as much as possible with our installed base of VAX VMS systems. Most of you who are out selling are selling into accounts that have VAX VMS systems installed, and they're looking at adding Unix systems to work in combination with their VMS systems. They're not looking to replace necessarily their VMS systems with Unix-based systems. So because we went with the same byte ordering that our VAXs used, it makes interoperability easier. So that's one reason why we chose to go with little Endian byte ordering. Another one is that if you look at market share in the Unix market, Intel-based systems have the largest market share. Now those are not just the systems that are running MS-DOS, which have the largest number of units overall. But if you look at in the Unix market specifically, Intel-based systems running SCO Unix are the largest number of seats that are out there. So it was important for us going into a market where we weren't already established to go with what the market leader in terms of unit volume was doing. Intel is little Endian, so that's another reason why Digital chose to go little Endian. And it's interesting to note that Sun themselves even had their own little Endian systems, the Sun 386i, which turned out to be a failure in the marketplace, but they realized that little Endian systems had value as well. And I think another thing that's important to point out to your customers is that as these Intel-based systems become more powerful, with the 386 and the 486-based systems now starting to come online, interoperability with those systems is going to become more and more important. So interoperability with little Endian systems that are based on Intel becomes of paramount importance in a lot of customers' environments, specifically people who are working on DOS or OS/2. So when you look at all of those things, you realize that Digital is not out in left field someplace. We're really the mainstream in terms of what's going on in the industry with respect to byte ordering. Now let's look at the second issue, where Sun will say that the reason that Digital did this is because they're closed or proprietary. That's just simply not the case. They're trying to create fear in your customer's mind because of Digital's heritage in VMS being a proprietary operating system. But let's really look at what the facts are, okay? The facts, first, is that MIPS developed their chips to work either in little Endian or big Endian mode, which means when they were developing their chips several years ago, back in the early 80s, they realized that this was an issue in the industry, and they designed their chips to work either way. Other system suppliers that use MIPS chose to go big Endian, and we can look at a couple of examples to see why they did that. For example, Silicon Graphics uses MIPS chips in a big Endian mode. The reason that they chose big Endian was because they wanted to maintain as much compatibility as they could with their installed base of customers. Their installed base when they switched over to MIPS was based on the Motorola 68000 family, which was a big Endian implementation. So Silicon Graphics chose to go the route that they did because they wanted to be as compatible as possible with their installed base, which is exactly what Digital did. We did the exact same thing, but we arrived at two different results because of where our installed base came from. One thing that Sun sort of implies in their whole conversation about byte ordering and Digital choosing little Endian is they imply that we tried to do something proprietary. Well, the fact of the matter is, if anybody were to go out and build a MIPS-based system today, they have a choice. They could do it little Endian or big Endian. And I would be willing to bet that if a new vendor were to come onto the marketplace with a MIPS-based product, they would come out with little Endian too. Because if you look at system vendors who build systems based on MIPS, digital is the leading supplier. And anybody who is going to build a clone type of system or a system built on MIPS architecture would go for where the market share is, and digital has the market share today on the MIPS-based line. Last but not least, if you look at it from the point of view of Sun saying that we're closed or proprietary, the reason that we did what we did was because we wanted to go with where the installed base was in our accounts. And if you look at the kind of computer systems that are installed in our accounts, they're primarily VAXs, which are little Endian, or IBM PCs or clones, which are also little Endian. So our real strategy there was to try to address the compatibility issues that customers were wrestling with. So it's the whole issue of DEC being closed and proprietary is really a red herring that Sun is trying to throw at our customers. The third point is, if we get back to the issue, Sun will say that we don't integrate well with other Unix systems. That's simply not the case. Let's take an example and look at the X window system. The X window system was designed from the ground up, recognizing that there are little Endian systems in the world and there are big Endian systems in the world. So because X was designed that way, it interoperates seamlessly in an environment where there are big Endian and little Endian machines. But the key there is the fact that it was designed from the ground up, realizing that X Windows had to be portable, and it had to recognize that there were different hardware architectures out there. And that kind of gets to the crux of the matter. Big and little Endian is an industry-wide problem. It is not a digital problem. As long as there are computer systems, there are going to continue to be big Endian systems, and there are going to be little Endian systems. And the problem is just going to get worse in the future as we start moving from 32-bit computers to 64-bit computers. And what's going to happen is that people are going to realize that if they have code that was built to be architecture specific, that is not portable, those applications are going to break. So what we need to do is work with customers to realize that big and little Endian is an industry-wide problem, and the way that it can be solved is by basing applications on industry standards and developing portable code. So let's look at when byte ordering is an issue for your customers and when it isn't an issue, so that you can really cut through all of the FUD that Sun is moving around and try to get down to solving the customer's problem, which is really what this whole thing is about. First of all, byte ordering is not an issue when what needs to be interchanged in the environment is simply ASCII files. For example, if I'm sending mail from my system to a Sun system, ASCII files, because of the way they're oriented, can be sent across the network, and byte ordering is not an issue there. So one of the things that you can do is you can use ASCII files as a way to interchange data back and forth between different applications. So if you're simply moving ASCII files around, byte ordering is not an issue. A second place where byte ordering is not an issue is when applications take care of it themselves. And if you look at it, that's typically what happens in most off-the-shelf third-party applications. These vendors have versions that run on DEC systems, and they have versions that run on Sun and on IBM and HP, and the application vendors themselves have solved the problem. They have their own internal data formats in their applications, and they have conversion utilities built into their applications that make byte ordering a non-issue as well. So if it's an off-the-shelf application from a third party, in most cases, the byte ordering issue has been solved for you by the application vendor themselves. Last but not least, byte ordering is not an issue when applications are coded based on a set of standards that allow for portability, okay? So if customers are developing new applications, or they're looking at converting old applications that were not portable, they need to design those from the ground up using industry standard application programming interfaces, and they also need to develop them in such a way that they are not dependent on byte ordering. Let me give you an example of how that works. In the digital environment, we have something called CDA, the Compound Document Architecture. CDA is an application programming interface, or a set of application programming interfaces that hide the underlying hardware architecture from the application programmer. Now, CDA is typically oriented towards compound documents, or documents that include text and graphics and images, but the same type of model could be expanded to deal with other types of data, not just documents. But CDA is an example of an application programming interface that allows for portability and allows code to be written once and deployed on different systems regardless of their byte ordering. So CDA is an example. It's not necessarily the be-all and end-all of application programming interfaces, but it can serve as a model for customers to understand what's necessary. So let's look for a minute now at where some of the cases where byte ordering is in fact an issue and where it can cause you significant amounts of difficulty in trying to sell into accounts. The primary area where byte ordering is an issue is in what is typically called in the industry dusty deck applications. What they mean by that is applications that have been around since the world was flat, things that have just been around for a long time, code that was developed back when the issues of portability were not apparent in the industry, and people coded things in an unportable fashion. Oftentimes, customers have those types of applications in-house, and they might not have access to the source files. Or, for example, the company might have gone out of business or something like that. In those types of environments, the byte ordering issue can be very significant because what happens is that those applications don't understand the fact that if you move data around, the data might be little endian and it comes from a big endian system, for example. So in those types of application environments, there are a couple of things that you can do. One is to actually work with the customer to try to convince them that it's worth their while to move that old code into a new portable environment. And that's really, if this is an important application to them, is something that they should be considering in terms of the long-term viability of that application. As it moves forward, as new architectures come online, it's really important for that application to be portable. So that's one aspect that you can look at is it worth for the customer and for you as the digital account manager to encourage them to move that application forward and to make it coded in a portable fashion. Another thing that you can do is there are actually utilities on the market that can take data files, existing data files in big endian format and convert them to little endian format. There was actually a review in Digital Review back earlier this year in the summer about a product from Accelerate Technologies called Trans-LR8, which will actually take files, and if you know the format of the file, you can actually convert them on the fly. So that's another example of how you can take and move the data from big endian to little endian format. Those are really about the two approaches that are available today. Within engineering, we are looking at other approaches that are available, and there might be some engineering solutions forthcoming in the future, but those won't help you today. The examples that I've given you are ways that you can actually help your customers today and let them start thinking about this in the future. One myth that I'd like to put to rest that seems to be moving around in the field right now is that the new chip, which is used in the DEC-Station 5000 and in the DEC System 5100 and the 5500, is a chip called the R3000A. There are rumors going around in the field that that chip will allow you to run code in either big endian or little endian mode, and it can be switched on the fly. The real story there is that the hardware to do that is in place, but the software to do that is not. So it's not a solution to your customers' problems, at least not in the short term. That is the vehicle that we're looking at for solving this problem in a more generic fashion in the future, but please don't start telling your customers that they can do this today, because the rest of what's necessary to make that happen is not in place yet. So understand that that's something that engineering is working on, but it won't help you here and now. There are other solutions to help you in the here and now. That's it.